Hello guys, with the name of God Ram Ram, I am Kumar K. And today we are going to solve a very interesting online assessment problem which was asked in Walmart OA, okay, for a very good package, okay. So before we start solving this problem, let me introduce myself. I am Kumar K. Previously, I worked at Amazon and Via.net as a software engineer. I cracked those offers off campus despite being from a tier 4 college. Also, coming to my love for DSA, I have All India rank 12 in Google Code Gem 2021 out of 1 lakh people. Also, I have All India rank 4 and World rank 48 in the recent Meta Facebook, whatever you want to call it, Hacker Cup 2024. And now I spend all my time doing the things which I'm passionate about, like, guiding and training students so they can get and reach their final goals and get the top tech skills and the top tech jobs. Now, guys, if you click at the first link, the link to the problem will open up. Okay. So always remember, see, the online assessment questions look like this. Can you see so many paragraphs are there, right? To understand, it is a 5-page question. Okay. So always remember that whenever you are trying to crack an online assessment of a top tech company off campus or on campus, your English comprehension skills should be very good. Okay, English comprehension skills should be very, very good. You should have the strength to read large English paragraphs and summarize them in 1 to 2 lines. Okay, you should be able to summarize them in 1 to 2 lines. After you have summarized them in 1 to 2 lines, you should be able to solve the hard unseen DSA problem given to you. Please know that the online assessment questions will never be a standard popular question from popular DSA sheet. No, it will never happen. It will be a totally new question. Just like you used to face new question in, let's say, JEE Main Mathematics or JEE Advanced Mathematics. Always new questions come in the exam, right? So here, this is a totally new DSA question. You can only solve it if you have done lots of OA and CP and new DSA questions practice of online assessment of all top tech companies of recent months and previous years. So if you want that, you can join our personalized one-to-one mentoring and day life training and 8 plus 850-hour high quality structured course program. Now, coming to this question, guys, they are saying maximum sequence. So you can read the story and you can try to make sense of it yourself. I will try to give you some easy understanding of the problem. They are saying that we are giving you n. You will be given n, guys. You will be given n. Let's say n equal to 5. It means you have to assume that you have a sequence of 1, 2, 3, 4, 5. All the numbers from 1 to n you have with you. Okay. Now, what do we need to do here? What do we need to do here? In each step, we have to print the GCD of the sequence. We have to print the GCD of the sequence. Okay. So I will print the GCD of this sequence here. Okay. So let's say the GCD of this is what? 1. I will print 1. But after that, I have to remove any one element from this sequence. After I print the GCD of the sequence, I have to remove any one element from the sequence. And we have to remove that number of our choice from that sequence. And then whatever is the remaining sequence, again print the GCD, again remove one number, again print the GCD, again remove one number. Do this process until the sequence becomes empty. So guys, here you can see that I printed 1. Let's say I remove 4 now. So I remove 4, my sequence looks like 1, 2, 3, 5. Okay. So what is the GCD? 1. I will print 1 again. Now let's say I remove 1 from the sequence. So my sequence is 2, 3, 5. What is the GCD? GCD of 2, 3, 5 is 1 again. Now let's say I remove 2 from the sequence. My sequence looks like 3, 5. What is the GCD of 3, 5? 1 again. Let's say I remove 3 from the sequence. Now my sequence is 5. What is the GCD of 5? GCD of 5 is 5. So the total answer is 1, 1, 1, 1, 5. This is one of the possible answers. So that's what they are saying in the question, that we will give you an n. At each step, you print the GCD of the current sequence which you have, the GCD of the current sequence you have, remove any one number of your choice, and again print the GCD of the current sequence. Do this until the sequence is getting empty. Okay, so basically you have to print the GCD of n times, because it will take n moves to make the sequence empty. So this thing is clear to you and you guys nicely understand it, right? So much fun is there in life. Ha ha ha. So guys, the only requirement is that the sequence which you put print na should be lexicographically maximum. So your task is to make optimal choices smartly at each step. So your final output of n numbers is lexicographically maximum. Okay, so guys, let's discuss about the prerequisites for this problem. So the first prerequisite is that you should know what is the meaning of GCD, right? GCD of A comma B is nothing guys but the greatest number which divides A as well as B. For example, I want to calculate GCD of 4 comma 8. Which are the numbers which divide 4 as well as 8? 1. Yeah, 1 divides 4, 1 divides 8 as also. Good. So 1 is a possible candidate. Then 2. 2 divides 4. You know na 4 by 2 2. 2 divides 8. 8 by 2 4. The 2 is also a valid candidate which divide both the numbers. Can 3 be the GCD? No. 3 does not divide 4 nor 3 does divide 8. GCD can only be a number which is dividing all the elements of the sequence. Okay. Next valid guy is what? 4. Yes, 4 divides 4 and 4 divides 8. Now 5, 6, 7, now all these numbers can never divide 4 and 8. You will say, sir, but 8 is dividing 8. Yes, but 8 is not dividing 4. The number which you pick up should be able to divide this number as well as this number. Okay. So guys, which for GCD of 4 comma 8, these are the valid candidates. 1 can be the GCD, 2 can be the GCD, 4 can be the GCD. We want to know the greatest number. Greatest number is 4. So GCD of 4 comma 8 is 4. So hopefully you guys understood the meaning of GCD. Now let's talk about the lexicographical maximum sequence. So if I give you two sequences, and I ask you, this is sequence A and this is sequence B, which one is a lexicographically maximum sequence? So the definition is pretty simple. If I give you two sequences, sequence A and sequence B, and you want to find out the lexicographically maximum sequence, what you can do is travel from the left of both the arrays, both the sequences. Find the first index I from left such that AI is not equal to BI. So you found the first occurrence when both the array elements and index I are not matching. If at that index AI greater than BI, then A is the lexicographically maximum sequence. I will call it as LMS. A is the LMS. But if B of I is greater than A of I, then B is the LMS. So guys, let's do the algorithm. Let's travel from left, okay? So guys, at this index both are equal, so I will not do anything, okay? I will ignore. At this index both are equal, I will not do anything. This is the first index I. When I was saying that English comprehension skills, I remembered Amazon EC2 ECS instance. Anyways. So guys, this is the first index I where both of them are not matching. Which one is bigger? This is bigger. So B is the lexicographically maximum sequence. In terms of LMS, B is greater than A. Even though A is having greater elements afterwards, we don't check that. We only check from the left hand side. From the left hand side, you travel as soon as you find that, as soon as you find an index where both the array elements are not matching, you check which one is bigger. This one is bigger, B is lexicographically maximum than A. Okay. So these concepts are also clear. Okay. Now guys, how do we proceed to solve the problem? Well, if I go below, for n equal to 2, the solution is pretty simple. You consider this sequence 1 comma 2, right? You will print the GCD 1. Okay. But after printing that, what will happen if you remove 2? If I remove 2, 1 will be left in the sequence, and again the GCD will be what? 1. So final answer will be 1 comma 1. Is this the best answer possible? No. You can get a greater sequence than this, because we want the lexicographically maximum sequence. So the better option is, initially obviously the GCD will be 1 only. But instead of removing 2, I will remove 1. Remove 1. Now the leftover sequence is 2. The GCD of 2 is 2 only. Single number GCD is the number itself, right? Now 1 and 2. Now the sequence is 1 comma 2. Which one is better? Whose LMS is better? This is 1 comma 2. This LMS is better because this is the first index where both are not matching and 2 is bigger, so this is better. So 1 comma 2 is the answer. 1 comma 1 is not the answer because in terms of LMS, lexicographically maximum sequence, 1 comma 2 is better. So you have to optimally decide how to remove the numbers so that your LMS of the final answer is maximum. Such a brilliant problem, my goodness. Ram Ram, always say Ram Ram. Chant the name of God Ram. And you will always have the energy of God flowing through your veins. Now, this thing is clear. What will you do, bro, for 1, 2, 3? Well, you can come up with a lame solution that, sir, uh, first the GCD is 1, then, sir, I will remove 3. If you remove 3, what is going to happen? It will be like 1 comma 2. The GCD will again be 1. Then you will remove 2, and the sequence will look like 1, and the GCD will still be 1. So 1, 1, 1. 1, 1, 1 is one possible answer. Is this the best? No. You can get a better answer. What if you remove 2 in the start only? The remaining sequence is 1 comma 3. The GCD of 1 comma 3 is 1. But now you remove 1. You leave the largest element in the end like this. So the answer is now 3. So 113 is better than 111. So 113 is the LMS of this sequence if you follow the process of finding GCD and removing any one element optimally at each step. But guys, thousands of people were giving this Walmart online assessment. Now you just think what to do. What optimal strategy will you use to get your job done? You need the best optimal strategy, guys. You can do it, guys. You can do it. So, let's try to find the answer for n equal to 4. You guys might be thinking a shortcut trick, right? That, sir, I know what to do. You will say that, sir, the first time the GCD will be 1. Then, I will remove 1. Then the leftover elements will be 2, 3, 4, right? The GCD will be 1. Then I will remove 2. The leftover elements will be 3, 4. GCD will be 1. Then I will remove 3. Then the leftover element will be 4, which is a big number. And 1114 will be the answer. So guys, sir, for any n, the answer will be, I will write 1, 1, 1, 1, n minus 1 times because the GCD will always remain 1. Until the single element n is left, then I can say GCD is n. But this is a faulty approach, beta G. This is a faulty approach. Why? Because for 1, 2, 3, 4, a better answer than 1114 exists. See, for n equal to 2, you have seen, right? You have seen these things. For n equal to 3 also you have seen these things. See how nicely it has been analyzed for you. For n greater than equal to 4, or let's say for n equal to 4, okay? After this, I analyze the cases for n greater than equal to 4. So if n equal to 4, 1114 is not the correct answer. 1124 is the correct answer as it is the LMS. Now why 1124 is the correct answer? See guys, you know that one possible option is 1114. But I am saying that I can also bring 1124. How can you do that, sir? First I will remove 1. If I remove 1, what will I be left with? 2, 3, 4. Then I will remove 2, 3. Sorry, 3, not 2. If I remove 2, then it will be problematic, right? So I will remove 3. Then I have the sequence 2, comma 4. Now guys, can you see for this sequence? The GCD is 1. For this 2, 3, 4, the GCD is 1. But now you only have multiples of 2. Wow, 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 wow. All the numbers in the array are divisible by 2. So that GCD will be 2. 2 can divide 2, 2 can divide 4 also, bro. So now the GCD will be 2 and I will smartly remove the smaller number 2 now next time. 4 will be remaining. And now the brilliant thing has happened. The GCD has become 4. Wow, man. I really enjoy this thing. Wow. So now these things are done and these things are clear. Okay. 1124. But guys, still what is the trick? See, the first trick coming to the mind is na that no matter what n value is given, na, see, this is the n value given to you, right? So guys, initially what is going to happen is that you need to remove all the odd numbers. You need to remove these odd numbers, okay? You need to remove them one by one. You need to remove this guy, this guy, this guy, this guy, this guy. So as long as you're removing the odd numbers, the GCD will remain 1 only. If you remove 1, the GCD of 2, 3, 4, 5, 6, 7, 8, 9, 10 is still 1. Then if you remove 3, still the GCD is 1. So 1, then, see, first I will remove 1. But after removing 1, the GCD is still 1. Then I will remove 3. The GCD is still 1. Then I will remove 5. The GCD of the remaining sequence is still 1. Then I will remove 7. The GCD is still 1. Then I will remove 9. The GCD is still 1. No. After removing 9, okay. So before nothing was removed, the GCD was 1. Then after removing 1, it was this. But after you have removed 1, 3, 5, 7, 9, now 2, 4, 6, 8, 10. The multiples of 2 are there. So now the GCD will be 2, 2, 2 for some time. So guys, did you get it? No matter what n value is given, na, if n is equal to 10, na, if n is equal to 10, you know that half of the numbers, n by 2 numbers are odd numbers, right? So what I will do is for 5 times I will write 1 like this. 1, 1, 1, 1, 1. Okay. Now my 2 will come and this will become a lexicographical maximum sequence. In earlier case, what you were doing? You were writing 1 like this 9 times. And in the end, you were writing 10. But this sequence is better than this sequence because here at 5th position there is 2. And in your earlier cases at the 5th position also 1 was there. So no, this is a better case. So guys, do you understand? To get the lexicographical maximum sequence now, what I want is, guys, to get the lexicographical maximum sequence, what I want is that to get the lexicographically maximum sequence, guys, what do I want is that I need to get a number from the left hand side here which is greater than 1. If I can get a number greater than here 1 quickly, like at the initial indices, then I can say that yes, this is a lexicographically maximum sequence. इसलिए मैं ट्राई कर रहा हूँ कि भाई ये जो आंसर एरे है ना, इसमें 1 से बड़ा नंबर बहुत जल्दी आए. जितना जल्दी आएगा उतना बड़ा लेक्सियोग्राफिकली मैक्सिमम होगा ना, एलएमएस. और जिंदगी भर 1 आएगा, लास्ट में बड़ा नंबर आएगा तो नहीं चलेगा. बड़ा नंबर अपन को पहले चाहिए. 1 से बड़ा नंबर अपन को सीक्वेंस में पहले चाहिए. To get a LMS, this is a greedy approach. This is a greedy plus mathematical problem with deep observational analysis, bro. To get a lexicographically maximum sequence, you need to as quickly as possible on the left hand side in the answer array. So guys, the approach is fairly clear that you will always delete the odd numbers like this, and then when the even numbers are there, you know that the GCD will remain 2 for some time. Now, I will take you through some of the observations, guys. I will take you through some of the observations. So listen to my observations very, very carefully. Okay. So if I come below, you need to remove all the odd numbers. Until then, the GCD will always be 1 because, uh, see, whenever you are in the process of removing odd numbers, na, you will be having some numbers from 1 to n where some of them are odd and some of them are even. Guys, it is guaranteed, and it is also guaranteed that the even numbers 2 till n are always there. They are never disappearing. And only the odd numbers are disappearing. So guys, you can experiment it. You will come to know that GCD of odd comma even will always be odd, and in our you can analyze this deeply. Okay, in our case, until all odd numbers are removed, now the GCD will remain one only. You can really try it out. Okay. To reach the LMS, we need to make sure quickly a number greater than one comes in the sequence from the left hand side. Okay. From the left hand side. And this is the best way. Guys, for n equal to 10, you know guys what you will do? For n equal to 10, you know that you will be deleting 1, 3, and then 5, and then 7, and then 9, right? So what will happen if you do like that? 1, 1, 1, 1, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. Now the remaining numbers are what? 2, 4, 6, 8, 10. You know the GCD is what? 2. But guys, now which number to remove? This is the question, right? अब कौन सा number निकालें? Now once you have 2, 4, 6, and 10, you know all those are multiple of 2's, but you don't know now in which order to remove to further get bigger GCDs. Before I discuss that, guys, a thought can come in your mind that sir, you are always trying to remove odd numbers and trying to get multiples of 2. But sir, why did you not try to get multiple of 3? 3 is a bigger number than 2, na? It might give a bigger LMS. Okay, well, I will show it to you, beta. If I follow the method of removing odd numbers, then my sequence looks like this, right? Right, agree in your book if you agree that if I follow the first method of removing odd numbers, the sequence looks like this: 1, 1, 1, 1, 1, 2, and then there will be something. I don't care about the remaining part. But guys, if you try to get all the multiples of 3, you will have to remove much more numbers. If you only want multiples of 3, means you need to delete 1, you need to delete 2, 4, 5, 7, 8, 10. So how many numbers you have to delete? 1 number, 2 number, 3 number, 4 number, 5 number, 6 number, 7 number. So 7 times till then the GCD will remain 1 only. Okay. You can try it out. The GCD is gonna remain 1 only because you are deleting all the numbers except the numbers which are divisible by 3. So it is guaranteed actually that the GCD is gonna remain 1. And now the remaining elements will be 3, 6, and 9. So GCD of 3, 6, 9 all are divisible by 3, it will come 3. But there is no use of this. Why? Even though 3 might be bigger than the number here, but we always, for LMS, we check from left to right, right? If you go from left to right, this is the first place where they are not matching. And 2 is bigger, so this is still better in an LMS conceptual way. Hence proved you should always try to bring 2, because if you try to bring 2, it will win in the LMS race. It will 2 will come on the left hand side of the sequence earlier than 3, 4, 5, 6 comes. So it's always better to delete the odd numbers and get it to very quickly. So guys, now this much thing is clear to you, and the same thing was analyzed here, that what if you removed all multiples of 3, what if you removed all non-multiples of 3, non-multiples of 3 from the sequence, and then you would get GCD as 3 because 3 will divide all the multiples of 3, right? But see, LMS, in the LMS condition, 1 is greater than 2. Hence, proved that we should always try to get 2 as GCD initially in the sequence. Final solution: repeat this sequence whenever needed, which I'm explaining, and you guys can check the codes also. Okay. So, guys, for now, you understand, because you are a Kumar K student, you understand that at this stage, the sequence looks like 2, 4, 6, 8, 10. Now, guys, what to do? Use your brain. I will give you some hint. Repeat the same old pattern. At this position, when you come at this place in the answer array, you know the GCD is 2, 2 is dividing all these numbers. Now, which number should you remove? Make a greedy choice which will help you now also and in the future also. Now guys, my lovely people, you need to remove all the odd positions in this number again. So you need to remove 2, then 6, then 10. Why is this working? See, when you remove 2 beta, what's happening is that 4, 6, 8, 10 will again have a GCD of 2 only, okay? When you remove 6, the GCD of 4, 8, 10 will be 2 only. But when you remove 10, what will be the leftover part? 2, 6, 10 removed, 4 comma 8. And guys, 4 comma 8 has a bigger GCD of 4. So again, if you remove the odd positions, then the leftover numbers will be having a GCD multiplied by 2 of the current GCD. So here the 4 will come. Now in 4 comma 8, again I will remove the odd position 4. So 8 is remaining 8. So guys, hopefully you have understood the answer now. That the smartest thing to do is that always keep on removing the odd positions. This is a brilliant observation, by the way. So that's it, guys. That's it. Hopefully you enjoyed it. Okay, but still, I will do it for a large number for you, like n equal to 20, and then we'll wrap up the session. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then here we go 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So guys, now what we can do is that listen to me very very carefully, okay? So first what we will do, n by 2 elements are odd numbers, so I will remove this. So guys, you understand that you have to remove all the odd numbers, right? So there are n by 2 odd numbers. You know the formula of odd numbers. In n, there are n by 2 odd numbers. And if n is odd, it is n by 2 plus 1. This much knowledge you should have, right, at this point. So now, in this particular case, you come to know that you will be printing 1 how many times? 10 times. After that, 2, 4, 6, 8, 10 will be there till 20. So how many numbers are there? 2, 4, 6, 8, 10, and 12, 14, 16, 18, and till the end. So here how many odd positions will be there? 5 odd positions, right? It will cut to then 6, then 10, 14, 18, and like this, right? So for 5 times the GCD will remain 2. Now out of this 5, for 3 places, you will be getting 4. You will again remove the odd numbers, then you will get 5, 3, one time the GCD will be 8, and the one time the GCD will be 16. So like this, one time, and the problem gets solved. So you can check the implementations also, and I will say that even if you understood the solution, please spend some time in understanding how the things are working, how the GCD is coming, and why this is the only best way. Whatever logic we applied in getting 1 to 2, na same greedy logic can be applied why you should try to get a 4 immediately after 2. Okay, so the logic just overflows, and you can check the C++ Python codes here. You will really find them very very interesting. Okay, so you can check the C++ implementation, Java and Python implementations, all are there. Java implementation is also there, C++ is also there, and our love for Python. Guys, what Python implementation is also there. You guys can check it out. So hope you guys enjoyed it. Take care. Love you all. In the name of God, Ram.